The first thing we need to know about conditions is that they are based on relational operations. So the relational operations checks the relation between two values, a variable which contain a value with another variable, or like x and y, as we see on the table, or between a variable and a value directly. Usually, the relational operations in conditions are some kind of questions. For example, when we say x equal to y, and here we use the equality operator, actually we're asking a question, is x equal to y? And the answer determines the result of that condition. So the result of the condition, either true or false, depends on the answer to this question about the relationship between x and y. For example, if we say, let's check a value, equals to 10 over 2. This is true. So here we compare two values. The first is a constant, and the second is the result of a mathematical operation. And since the result of the mathematical operations is equal to the value on the left side, so the result is true. Or we can say, for example, negative, then 0. This is a false statement. Also, we have the not equal operator. For example, if we say 1 not equal to 0, so it is true. It could be between variables, like x equals to 8 and y equals to minus 8. So we can say x equal to y, or we can compare the variable with constant. It's not like assignment operator. Be careful in this point. Assignment operator requires the variable to be always on the left side. For example, when we say x equal to 8, so in assignment, x should be in the left side. In relational operators, the variables could be in the right side. For example, I can say, is 100 larger than x? And it works. So here we have the ability to put the variable in the left or right side of the relational operator, because it is just a comparison between two sides. It's not an assignment operator. And it is a very common mistake to confuse between the double equal sign, which is a relational operator, and single equal sign, which is an assignment operator. So be careful. Let's test something which is mostly related to scientific computation, which is the degree of accuracy of a real number. In many cases, the output of functions, although it is expected to be an exact number like 1, some functions return values like, as we see here, like 0.99999, or sometimes 0.000001 instead of 0. So how much accurate the value is considered compared to the exact value? Now, if we try to check, is 1 equal to 0.999 with 9 or 12 nines. So if I press enter, I'll see that 12 nines after the decimal point are still not equal to 1. However, if I add more nines, now we have 16 nines, are still false. Now let me add more 2 nines. Now it's true. So what's going on here? Actually, this is not related to the conditions. It's related to the degree of accuracy of the float numbers. The float numbers have a degree of accuracy is about like 17 digits after the decimal point. So any number, even if it is very close to the accurate or exact number, it is considered different. In Python, also, in addition to the relational operators, we have logical operators. And the logical operators help us to create compound conditions depending on the relationship between the two conditions. For example, 5 is equal to 10 over 2, and 5 is less than 10. So this statement is true. Why? Because the operator AND requires that both sides must be true, so the overall result should be true. We can test it simply in this way. True and true are true. If we change the situation, for example, if we say 5 is equal to 2 over 10, if we test this situation, the AND operator will give us false, because one of the sides is false, while AND requires that both sides must be true. And we can test it this way. True and false. If both of them are false, if we change this one, again we have false, because if we test false and false, the result is false. Or returns true if one of both sides is true. So one is enough to return a true outcome for OR. For example, we get true. Why? Because both sides are true. So true or true is true. However, if we say 5 equals to 2 over 10 on the right side, we get true. Why? Because the first statement is true. We can check it in this way. True or false. What if both are false? For example, this could be not equal. So in this case, we get false, because the two statements are false. We can check it in this way. Or. So OR requires that at least one of the conditions in either side is true, so the outcome will be true. But if both of them are false, so the outcome will be false. Of course, if both of them are true, we get true. The final operator is not. And not actually is a negation operator. That means it turns the outcome of the condition to the opposite. So if it is true, it will be turned to false, and if it is false, it will be turned to true. Let's test it simply. If we say not 5 equal to 10 over 2, so it is false. Why? Because it is true statement, and we can test it this way. Not true is false. Oppositely, if we say not 5 is larger than 10, which is false, so not false is true. Not false is true.